Heightened, you've made it to the very end as far as end behavior goes. And behavior is more notation than anything, but it is actually, once it's broken down to its bare bones, not that difficult. So we can see example number one. So I'm looking at this first example over here. If I were to draw some arrows, those are not the prettiest, but I can see that my arrows are both pointing down. That means, because they're pointing down, that is going to tell me that my end behavior is going to be the same. And I'm basically looking at, if it's going down, it's going to go to negative infinity. So you would say, in its fancy languages, f of x approaches negative infinity. So that just means on the left-hand side, what is my graph doing? So on the left-hand side, I've got myself a down arrow. So I'm going to say on the left-hand side, I'm just going to negative infinity. Ouch, ouch. And because this graph is opening down on both sides, it means it was, as far as its exponent goes, it's the highest exponent is an even number, not that the graph itself, not that the function itself is even, but it's an even amount of polynomial answers. Left-hand side is negative infinity because it is even in the sense that they are facing the same way. On the right-hand side, also negative infinity. Odd functions, not odd in the sense that they have the reflection properties of even and odd, but odd meaning that they're polynomial, so meaning that their highest exponent is an odd number. Odd things are going to have different directions. So, if I can, as you can see, on the left-hand side, that is pointing up. So that means it's f of x, and I'll pop over to the notation in a second. That means on the left-hand side, my left-hand side of the graph is pointing up, and then on the right-hand side, so the second part, is pointing down. That is one way that I can tell that I have an odd polynomial, not necessarily an odd function. Okay? Same thing kind of reiterates in example number 3. On the left-hand side, it would be headed down, so therefore negative infinity. On the right-hand side, it's pointing up. So because those two things are different, we would call that an odd polynomial. And then in example 4, I can see that this is headed towards positive infinity on both sides. So since it is positive on both sides, it's opening up. So that means it would have been some type of even polynomial, not necessarily when it comes to its symmetry. So those are things you can use to describe. This one's opening down. So since it's opening down, it's pointing down, we would call this would have been a negative even talking about its degree. It's a negative even degree. And I can tell that because my end behaviors are both negative. Because my final end behavior over here is negative, I can tell that this one is a negative odd degree, simply because of what's happening on the right-hand side. Because these two things are opposites, I can tell that this, and because it's going eventually to the positive on the right-hand side, this is a positive odd degree, and this one would have been positive even, if I can get it to work. Positive even, because both are pointing